So let us discuss the second section of the MOS transistor device and its characteristics. So we have two type of the MOS transistor, CMOS transistor. One is enhanced mode transistor and another one is the depletion mode transistor, which we already discussed. Let us discuss about the mechanism of the enhanced mode transistor. The enhanced mode transistor is having the three type of the conditions, like as we know that enhanced mode transistor is initially there is no channel, source is one side, drain is one side, channel is formed in between, and above we have a oxide layer and above we have a metal layer to form the gate and other layers. So first we recognize that in order to establish the channel, the first place is the minimum amount of the voltage we need to apply, that is called threshold voltage, which will be must and should to establish the channel. So between the gate and the source we have to apply some kind of the voltage, which is the threshold voltage. Once it is happened, the condition is prevailing the channel to be established, but no current will be flowing between source and drain, because minimum amount is there, which is the VDS is approximately 0. So now let us conditions are prevailing that when current flowing in the channel by applying, when VDS is between drain and source, so let us apply the VDS between drain and source, that is VGS is greater than VT, because we have already minimum threshold voltage and we have to apply VGS greater than VT, and VDS is 0. That is the first condition. Second condition is VGS is already crossed the threshold voltage, and VDS, that is the VGS minus VT, and it should be less. So the potential will be drop along the channel. So voltage between the gate and the channel varying the distance between the channel, therefore the maximum VGS at the source end. So Vg equal to VGS minus VT, no current will be flow at this condition, but there will be a voltage available to invert the channel at the drain side, as long as VGS minus VT is close to VDS. So the limited conditions are when VDS is VGS minus VT, but for other than all these VDS is less than VGS minus VT, the device is in a non-saturation region of the operations, but there is a slowly the flow of the electrons. So consider now what happens when VGS is increases further, which is greater than of the VGS minus VT, that is the third conditions. Then the IR drop will be happen and the length of the channel, therefore the channel length near to the drain, there is insufficient electric field available. So the electric field gives rise to an inversion layer to create the channel. So the channel, therefore the channel is created, slowly number of electrons will be go, then VDS is increases more and more, then the depletion width will be increases, then after certain maximum voltage is given VDS, there is a pinch off condition will be happen. So this region is known as the saturation region, where this is almost all constant current maintained by increasing the VDS which is above the VGS minus VT. So this is the third state, where that is the saturation state. So the first state is non-conducting state, the second one is the non-saturation state, third one is the saturation state. Based on all these, typically enhanced mode devices will have the threshold voltage is 1 volt and VDD is 5 volts, and general terms of threshold voltage is 0.2 into VDD. So in this way the enhanced mode devices will be operates. And the depletion mode transistors, the depletion mode devices, the channel is already established due to the implantation, VGS is 0, but to cause the channel to exist, the negative voltage we need to provide between the gate and the source. Here in this case it is typically minus 0.8 VDD, which is depending upon the implant and substrate biasing, and also threshold voltage difference is apart. So this the action is similar to the enhanced mode transistor, and we can see the symbols of the NMOS and PMOS transistor, which is figured out here. This is the symbol of the NMOS transistor, and this is the direction flow of the direction. It is usually used, the bottom symbols are usually used, very commonly used or generally used NMOS and NMOS depletion layer, depletion transistor, and this is the PMOS. In the PMOS we can see there is a bubble at the gate that indicates that it is the PMOS, and there is no bubble at the NMOS. That is the main difference in case of the NMOS and PMOS in terms of the symbols as far as it is concerning.